So what we're starting today is factoring. So we're going over factoring again. And this time we're going to be dealing with factoring these polynomial functions, factoring these higher degree polynomial functions. And we're going to go over different ways to factor it. And again, what we're doing with this here and division is really leading up to solving. Because factoring is going to be one of the ways that we can solve these higher degree polynomial functions. We use division to solve, to be able to reduce the powers. And we'll see how all of this culminates next week, because we'll finish up this part tomorrow, and then we'll finish up factoring on Friday. But this here is one of the ways that we can go about solving. Now, the first types that we look at is really looking at greatest common factor, and then using the ways that we know already to factor them completely. And when we talk about factoring each polynomial completely, is being that it doesn't have a greatest common factor in any of the parentheses, and we reduce it all the way down as far as it will go. So when we look at this here, for A, is there a greatest common factor between x cubed, negative 4x squared, and negative 5x? Is there something in common with all three? They all have an x. So we can factor it out. If there is a greatest common factor, be it a number or a variable or both, we can factor it out. We can simplify this down. Now, if I factor an x out of x cubed, I'm left with x to the second power. I'm pulling one of them out. Minus 4, we're not factoring anything out of the number, but I'm reducing x squared to x minus 5. We reduce each one of those terms, the x terms, by 1, because we factored one of the terms out of the entire polynomial function, which leaves us with x times x squared minus 4x minus 5. So we factored an x out. Now, we've factored x squared minus 4x minus 5 before. We've done that one before. We did that in the last chapter. So we can factor this here. And the first way that we factor this is by writing two sets of parentheses with 3 spaces. Because it's factorable, so our first step is to write two sets of parentheses with 3 spaces. Our next is the sign. So we look at the constant term. And if the constant term is negative, the signs are opposite. One is positive, one is negative. So we can go on and put those in. Any questions on any of this here so far? Any questions on anything we've done so far? Now, at this point here, we look at the factors of the first and third term. Well, the factors of x squared are going to be x and x, because there's only one set of factors for x squared. Now, when we look at 5, well, again, there's only one set of factors for it, which are 1 and 5. Now, we need to check to make sure we have it all set up correctly. So we can do x times negative 5, which would be negative 5x. And 1 times x would be plus x, because it's positive. Negative 5x plus x is negative 4x. And again, that's what we're looking for. So it works out this thing here is factored. It is factored completely. There's no greatest common factors inside any of the sets of parentheses. And in each side of the parentheses, the degree is 1. These here are as simplified as they can go, or as simplified as we can get them. And that's all we need to do for this here. Questions on this here? Any questions on letter A, the first problem we've done so far with this factoring? So this should seem very similar to what we've done before, what we did in the last chapter with factoring, except now we're factoring out a greatest common factor that can have variables. That can have a variable. Well, let's look at the next one here. 3y to the 5th minus 48y cubed. Is there a greatest common factor between 3y to the 5th and negative 48y to the 3rd? Is there a greatest common factor between these two terms? I'd say y to the what? Third. Because there are at least 3 y's in both terms, in both of those terms. So we do have that. Is there any other greatest common factor between these two terms here? 3. 3 will go into both 3 and 48. So the greatest common factor between these two terms here is 3y cubed. 3y cubed is the greatest common factor between these two terms. So we need to factor it out. So when I factor 3 out of 3, or 3 divided by 3, I get 1. Now y to the 5th divided by y cubed, or if I take 3 y's away from y to the 5th, I'm left with y to the what? 2nd. Because I had 5 total, I take 3 away, I'm left with 2. Minus. Well, 48 divided by 3 would be 16. We can do 48 divided by 3 in the calculator. Now, if I have 3 y's, I take 3 away. It reduces to 1. It simplifies out. Any questions on this here? Any questions on anything we've done so far? So there was a greatest common factor of 3y cubed, 3y to the 3rd, and we factored it out of both terms. Now we need to see, is what's left inside, y squared minus 16, is this factorable? Because if it is, we need to factor it. And it works out y squared minus 16 is actually a special setup. It's a difference of perfect squares, because y squared is a perfect square. 16 is a perfect square, and they are being subtracted. So this is factorable. Now, since the 16 is negative, the signs would be opposite. Our factors of y squared would be y and y. And the factors of 16, well, there are a few, because we could do 1 and 16, 2 and 8, 4 and 4. Well, the ones we want are 4 and 4, because it is a difference of perfect squares. This one here is a difference of perfect squares, so we should know that it is 4 and 4. Now, if we're not sure, we can always check it to make sure. Multiply through. Well, y times negative 4 is negative 4y. And 4 times y would be plus 4y. And negative 4y plus 4y gives me 0. And this here is factored completely, because inside each one of those parentheses, I do not have any greatest common factor. There's nothing in common with y and 4. The degree for both of these is 1. So when we're checking to make sure that it is factored completely, we're looking inside each one of these sets of parentheses and seeing, is the degree 1? If it is, we're done. If the degree is not 1, we need to make sure it's factorable, because if it is factorable, we need to factor it. If it's not, we're finished. We don't have to do anything else. Any questions on this here? Any questions on anything we've done so far? We ready for the next one? Yes? Okay, let's look at this one here. Let's look at letter C. 5z to the 4th plus 30z cubed plus 45z squared. So if I'm wanting to factor this, I need to see, is there a greatest common factor between all 3 terms? Is there a greatest common factor between 5z to the 4th, 30z cubed, and 45z squared? Z squared and 5, because 5 will go into 5, 30, and 45. All 3 are divisible by 5. And it works out 5 is the biggest number that will go onto all 3. And z squared is the biggest variable that will go into all 3. So we can factor it out. Well, 5 divided by 5, or 5 factored out of 5, would leave us with 1. Z to the 4th, if I factor z squared out, or I pull 2 z's, away from z to the fourth, I'm left with z squared. I had 4, I took 2 away, so I'm left with 2. So that's our first term. Plus 30 divided by 5 would be 6. Or if I factor 5 out of 30, I'm left with 6. Z to the third divided by z squared, or z to the third. If I factor 2 out, or I take 2 away from z to the third, I'm left with z. And lastly, 45 divided by 5 would be 9. And the z squared divided by z squared, or z squared, take 2 of them away, I don't have any left. It's 1. They factor out completely. Any questions on how we factored out 5z squared from this here? Any questions on this here? Okay. So we have the 5z squared factored out. We just need to see, will this factor? And it will. For this problem here, this will factor. So we'll set up our 2 sets of parentheses to factor this. Since the 9 is positive, the signs are the same and they match the sign of the middle term. So we have positive and positive. Now the factors of z squared would be z and z. Now the factors of 9, there's only 2 sets of factors. We have 1 and 9 and 3 and 3. So which ones would we use? 1 and 9 or 3 and 3? 3 and 3. And if we check this here, z times 3 would be 3z. And 3 times z would be plus 3z, which gives us a positive 6z, which is exactly what we wanted. Now we are done, because if we look at both of these parentheses, there's not a greatest common factor between z and 3. There's nothing in common between z and 3, is there? No. They're different terms. And when I look at the powers, z is to the first, z is to the first. The degree of both of these parentheses is 1. We cannot factor them any further. If the degree inside either one of the parentheses is greater than 1, we need to check to make sure that they have been reduced fully, that it is not factorable. Questions on this here? Any questions on anything we've done so far? All right. We're going to look at one more of this type, and then we'll kind of move on to the next example. So what we're going to look at next is this here, x cubed plus 10x squared plus 24x. We're going to look at this polynomial here. Now again, just like what we've been doing, is there a greatest common factor between all 3 terms? Between x cubed, 10x squared, and 24x. What do they all have in common? X, well, x, yes. Now I can't take x squared because of the 24x, because x is the biggest one it has. Because the most that I can take out of any 3 is 1 of them, because the smallest of the 3 is 1. If this had been x squared cubed fourth, then we could have taken 2. All right, guys. So what we need to do next is we need to factor this x out. So if I factor 1x out of x to the third, I'm left with what? X squared, because there were 3. I factored 1 out. I pulled 1 out of there, so I'm only have 2 left. Plus, here I have 10x squared, and if I factor 1x out, I take one of those x's away, I'm left with 10x plus 24. Since there was only 1x there, I took it away. We just have 24 left.
Will there ever be a time where you can't get a variable out? Like
Yes.
if it was x cubed, x squared, and then just 24?
Like this here?
Yeah.
Yeah. There's cases where we'll come across something like this here. And just like with quadratics, how factoring didn't always work, factoring doesn't always work for these here. But if I can factor it down, it makes it easier to solve. And I'll explain more in detail when we factor this, exactly why it works out that way. But before we delve into that, are there any questions on how we factored out x? Well, this here does factor. So we have two sets of parentheses with 3 spaces. And because the 24 is positive, the constant term is positive, the signs are the same and they match the sign of the middle term, which is also positive. So I have positive and positive. Now the factors of x squared would be x and x, because there's only one set of factors that multiply together to give me x squared, and it has to be x and x. Now the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of these would we use for this one here? 4 and 6. And if we check this here, x times 6 would give us 6x. 4 times x would be plus 4x, which gives us 10x like we wanted, yes? Now, and that's the correct one, that's the one we need. Are there any questions on this here? Any questions on how we factor this? Now, when we solve this, we're solving it for when it equals 0, yes? We're trying to find out what value of x will make this 0. And our zero product property said when I have any multiple things multiplied together that equal 0, one of them has to be 0. So I can set these all equal to 0 to be able to solve. So if we wanted to solve these, we could set them equal to 0, because any 2 or more things multiplied together equal 0. One of them has to be 0. So we could solve it this way here. So this would be minus 6, not plus. And we could do it that way. So factoring, if it does work, it's great, because when solving, we can set them equal to 0 and solve. They won't always work out that way. We'll have to find another method. And we do have other methods for solving. So any questions on factoring, how we factored these here? We feel okay with this here? Okay. We feel good about that. We're going to move on to these here, special factors. Sum and difference of perfect cubes. Now, these aren't in your note sheet, so I want you to make sure these are written down in your notes, that a cubed plus b cubed equals parentheses a plus b times a squared minus ab plus b squared. And the difference of two cubes, a cubed minus b cubed, is a minus b times a squared plus ab plus b squared. Does everybody have this copied down? Not yet. Now with this here, so I know you're still copying it down, but this here, there is a specific pattern to how these work. There's a specific pattern to how these work. Because if we look at the variables, because I have a squared, a, and then the last one does not have an a term. We have b, no b, b, b squared. So it's almost a, and then in the bigger set of parentheses, a squared, a is gone. So the powers of a are decreasing. So the one that doesn't have a, it's really a to the 0 power, but anything to the 0 power is 1, so we don't write it in. B is going in the opposite direction. B is increasing. We have b to the 0, which we don't write, b and b squared, so it's going up. One's going down, the other is going up. The same is true with the difference. A and B are matching in that way. Yes? Y'all kind of see that here? And it's going to work that way every single time, and that's going to help us with writing these in. Now, there's a specific pattern to these signs, and that's what we're going to look at now. So when we look at the signs here, the pattern is pretty much going to be the same, opposite, always end on a positive note. The signs are the same, opposite, always end on a positive note. And it works out this way every single time. They just follow this pattern. Now let's look at a difference, sum and difference of perfect cubes, and let's actually factor these. Now when we factor these here, the first thing we need to know is, are these two terms perfect cubes? Well, I can do that by taking the cubed root of both of the numbers, both of these terms. Now what would be the cubed root of x to the third? X, because the cubed root and the third power simplify to just x. Now we want to take the cubed root of 125. For the graphing calculators, you can hit math, and I think the fourth or fifth one down is the cubed root. And you can do that and type in 125. And if we take the cubed root of 125, we get, or should get, 5. So what that's telling me is that both of these terms, x cubed and 125, are perfect cubes. So we have the difference of perfect cubes. Now, with factoring, we normally set up 2 sets of parentheses with 3 spaces. Well, it's going to be a little bit different here. I call this one a tractor trailer because the first set of parentheses will have 3, and the second set would have 5. Now, let's look at the signs first. Now, we said the signs, so on any of these here, so since it's negative, it would be the same, opposite, always end on a positive note. Same, opposite, always end on a positive note. Since it's subtraction, the first one would be negative, opposite of negative would be positive, always ended on a positive note. Any questions on this here so far? Okay, now our A term is going to be x. So in the general equation, it was a minus b, a squared plus ab plus b squared. For us, a is just x. So we would have x. Here, this would be x squared. Then we'd have x to the first, and then no x. X in the first spot. We move over to the second set of parentheses, so x squared, x, no x. Questions on how we plugged in the first term? Any questions on how we plug this in? So we're just plugging in x where it is and having its corresponding powers. Now b in this case is 5. So here I would have 5. Now the first one here, we don't have a b term. Second one would be 5 to the first. And this one here would be 5 squared. Any questions on how we plugged any of this in? Any questions on any of this here? Are we good with this here? Yes? Now we have one more step we need to do, because we can simplify this a little bit. The x minus 5 wouldn't simplify, but here x squared is well just going to be x squared plus x times 5 would be plus 5 squared is 25. And that's it. Now, if you notice, one of those degrees, or one of these parentheses, does have a degree greater than 1, yes? The second part is a quadratic. The second part of this is a quadratic. It does not factor. The quadratic that comes out of a sum or difference of perfect cubes will never factor. This thing here will never factor to anything lower than that there. It will not. It just does not factor anything further than that. X squared plus 5x plus 25 for this one here will not factor. That is as simplified as it gets. Now, if we get this on a problem solving it for values of x that would work, well, we're just going back to the quadratic formula to solve at this point. I would use the quadratic formula to solve this part of it. If I was trying to find the value for it, I would use this to solve for it. Any questions on how we factored this here? Any questions on this here? Let's look at another one. X squared minus 64. So this is the one below it on your note sheet. It's not to the right. We're going down one. X cubed minus 64. X cubed minus 64. So the first thing I need to look at is to see, are these perfect cubes? Can I take the cubed root of x cubed? Well, yes, it would just be x, because the cubed, the third power and the third root, they will cancel. Whenever the root and the power are the same, they cancel out. Now the cubed root of 64 would be what? It would be 4. Because 4 times 4 is 16, and 16 times 4 gives us 64. So these two here are perfect cubes. That means I can set up our parentheses with 3 spaces and parentheses with 5. Now 3 of these spaces are going to be the signs. Now the signs are the same, opposite, always end on a positive note. So since we have minus, our first sign would be minus, and then plus and plus. Same, opposite, always end on a positive note. Since it was negative, our first sign is negative. Opposite would be positive. Always ended on a positive note. A, the one that goes in the first spot would be x. Now over here we would have x squared, x to the first, and then x to the 0. Now we don't put x to the 0 because, well, anything to the 0 power is 1. Anything to the 0 power is 1, so we're not going to write it in. Now our b is 4. It's what goes the cube root of 4. With the x squared, we don't have a b term. The one in the middle, we're going to multiply x and 4. And lastly, we have 4 squared. Questions on this here? Now we just need to simplify this. Well, the x minus 4 is simplified. Well, x squared would be, well, x squared plus x times 4 is 4x, and 4 squared is 16. And we get this here. Any questions on this here? Any questions on this one here? We good with this here? Yes? Okay. Let's do this one here. This one will be the last one we do today. We may or may not finish it, but we'll start this one here. Can I take the cubed root of 16s to the 5th? What is the cubed root of 16? What times itself 3 times is 16? So 2 times 2 is 4, times 2 is 8. Well, that didn't quite work, did it? 3 times 3 is 9, times 3 is 27. So can I take the cubed root of 16 evenly? No, okay. Wait a minute. Is there a greatest common factor between 16s to the 5th and 54s squared? There is. It is 2s squared. Well, 2s squared factored out of 16, well, 2 out of 16 would give me 8s to the 3rd. 54 divided by 2 would be 27, and the s's would simplify out completely. So here there was a greatest common factor of 2s. That's why it wouldn't work originally, why I couldn't originally take the cubed root. But let's try again and see. Well, we just said the cubed root of 8 is 2, yes? And the cubed root of s to the 3rd is s. Now the cubed root of 27 would be 3. The cubed root of 27 would be 3. When we look at the signs, they would be the same, opposite, always end on a positive note. I want you to try to do these, plugging these numbers in and simplifying it on your own. We're going to pick up with this on Thursday. We'll pick up this tomorrow and finish up this problem and finish this note sheet. The homework assignment for 4.41 is already posted. It's already been posted. So if you want to start that, go on and start it. But these here do not, because we have not covered these here yet. We will cover them tomorrow. So that's all.